Hello students, today we are going to discuss the important topic in your the chapter, that is carbon and its compounds. In the last class already we have discussed regarding the formation of covalent bonds and the nature of carbon atoms. This part already completed. The next important part of this chapter is organic chemistry, that is organic compounds. What are the nomenclature, what are the some basic concept in organic chemistry, what are the terms used in organic chemistry. Let us discuss these things. So already you know, that is if you see, the whole compounds are divided into two parts. Then whole compounds in chemistry divided into two parts, that is, one is organic chemistry, organic compound, another is inorganic compounds. Both they differ in properties. On the basis of their properties, they are two types, organic compounds and inorganic compounds. But it has been observed that the organic compounds are very large in number compared to inorganic compounds. Because this is due to the important features of carbon. Only due to the important features of carbon, these organic compounds are large in number. Already we have discussed in the last class, that is catenation property of carbon, by which it can form a different variety of carbon chain. It can be straight chain, it can be branch chain, it can be cyclic chain, like this. As the catenation property of carbon mainly responsible that the formation of large number of compounds, organic compounds. That's why organic compounds are large in number. Another thing is carbon-carbon bond is stronger bond. That's why the compounds are exist and it is more stable. That's why variety of chain, carbon chain are produced due to the stable carbon-carbon bond. So these are the some features already we have discussed. So today we are going to discuss regarding some basic concept in organic chemistry. So let us start. What is the organic compound? What is the meaning of organic compounds? What is the organic compounds? Which type of compounds are called organic compounds? Mainly these are covalently bonded. These are covalently bonded carbon compounds. These are covalently bonded carbon compounds, especially mainly carbon is there, covalently bonded carbon compounds. Other than some carbonates, bicarbonates, bicarbonates, carbon monoxide, carbon dioxide, like this. So we can say, although it has carbonate containing carbon, bicarbonate also contain carbon, carbon monoxide, carbon dioxide, like this. But these are not organic compounds. It is not these compounds not satisfying the properties of organic compounds. So mainly these are covalently bonded carbon compounds. Covalently bonded carbon is the essential composition of organic compound. Without carbon, organic compound is not possible. This is the basic concept of organic chemistry, that it is the covalent compound containing carbon atoms. So organic compounds, if you see the properties, already we discussed in the covalent compound. The properties of organic compound is same as your covalent compound. Like this, you can write shortly: low BP, MP, low boiling point, low density, low BP, MP density, then insoluble in water normally, but some exceptions are there, we will read later. Normally insoluble in water, then do not conduct electricity. This is the some important properties. Then another important property these organic compounds are, that is characteristic smell, having specific odor. Specific odor. Specific odor means it has characteristic smells. That is also one important. Then another important property is combustible. Combustible nature means it catches fire. It is highly sensitive to heat and light also. So combustible nature, then less soluble water, low soluble, almost insoluble, low density, low boiling point, melting point. So these are some important properties of organic compounds. When the compounds satisfy this property, you can say these are the organic compounds. Very important thing is combustible and also specific odor, characteristic smell, characteristic odor. So these are the some important properties of organic compounds. Then what are the classification of organic compounds? What are the classification? If you see the classification of organic compound, the organic compound mainly classified on the basis of first the nature of carbon chain. It may be on the basis of carbon chain, it may be, these are maybe open chain compound, or it may be cyclic chain. Open chain means both end is open, another is cyclic chain. Cyclic chain means both end is closed, no free. The end, the starting carbon and end carbon will be again closed. So that is open chain. Open chain compound also called as aliphatic compound. Okay, and this cyclic compound, it is also again two types. Cyclic compound two types, that is your alicyclic, another is aromatic. Aroma means characteristic smells, aromatic compound. These are called as cyclic compound. These two, alicyclic and aromatic, you will read in higher class. These two part is not required to discuss. But remember, alicyclic and cyclic, these are closed chain. For example, like this, the ring is closed. Suppose this is to take like this. So these are the alicyclic compound, means closed cyclic structure, just like hexagon, pentagon, square. This type of shape is produced. So these are alicyclic. Aromatic, it has some same cyclic structure having carbon atom, but it has some different structures, and due to different structure, it has some characteristic order. So due to the characteristic order, it is called aromatic. So we can take example. Aromatic is benzene, this compound. Let us take one example for your knowledge. This is called benzene. You have heard the name, that is benzene, is a solvent. So these are some aromatic. These are aromatic compound, this is alicyclic compound. Only both are called cyclic compound, closed chain compound. This is open chain. Open chain compound, organic compounds are called aliphatic. This term. Then what are the types of aliphatic compound? Let us discuss. These are on the basis of closed chain and what? Open chain and closed chain, this is classification. then we can say it may be open chain, closed chain or like this, but mainly on the basis of the nature of group attached. Organic compounds, if you see, organic compounds had a specific characteristic. The characteristic of organic compound is mainly due to the presence of the particular group in organic compounds. The group present in all class of organic compound, there is a specific group present in organic compound. Due to this specific group, that is called functional group, organic compound has particular characteristics. So you can say what is that? That is called your functional group. That is called functional group. What is functional group in organic compound? Which type of structure is called functional group? Functional group means we can say that it is atom or group of atom or group of atom responsible the atom or group of atoms responsible for the characteristic of organic compound, responsible for the characteristic of the organic compound. That means it may be a single atom or a group of atoms responsible for the characteristic of the organic compound. That means the organic compound property mainly depends upon functional group. Every organic compound has a specific functional group. This either in atomic form or in a group of atoms form. For example, we will say some example. If OH group is there, this is called alcohol. This type of organic compound are called alcohol. If the group is like this, X means halogen. If halogen is there, these are called haloalkane. If the group like this, acid group is there, this is called carboxyl group, this is called hydroxyl group, this is halo group, hydroxyl group, halo group, carboxyl group, this is called carboxylic acid. This type of organic compound are called carboxylic acid. If the group contains CHO group, this is aldehyde group, this is called aldehyde. This type of organic compound are called aldehyde. So like this, if organic compound only carbon single bond is there, these are called alkane. If organic compound containing double bond, already we have read in the covalent bond, formation of covalent, single bond, double bond, triple bond. If carbon double bond is there, that is called alkene. These are called alkene. If organic compound containing triple bonds, that is called alkyne. So these are different types of organic compound, different class of organic compound. It depends upon the functional group present in the compound. If OH group is there, that is alcoholic group, that is alcohol, X haloalkane, acid carboxylic acid, aldehyde like this. CO group, if CO group is there, that is called ketone. This is called keto group, aldehyde group, carboxyl group, halo group, hydroxyl group, carbon single bond, carbon double bond, carbon triple bond. This group is called keto group, and the organic compound is called ketone. These are the name of class. Alcohol. These are class of organic compound. Class of organic compound means it has specific formula. having same functional group. If the functional group is same, then it is called one class of organic compounds. Alcohol means OH group. Acid means COH group, like this. These are the type of organic. This is also one classification of organic. So what I want to tell you, that organic compound on the basis of chain may be open chain or may be a closed chain. Open chain means suppose start like this. It's an open chain. This is a carbon. This is also carbon. This is open. But this is, you see, this is a closed. So open chain. This is open chain. You can say open chain. This is a closed chain. On that basis, either open chain or closed chain, that is aliphatic or that is called alicyclic or aromatic. But on the basis of functional group, organic compounds are different types. Some organic compounds are alcohol, carboxylic acid, aldehyde, ketone, like this. If amino group, this is amino group. If amino group, that is called amines. These are called amines. So many types of organic compounds are there. You will read detail in higher class, but in your class up to class 10th, only some basic concept is required. So it will be easy in your higher class. So on the basis of functional group, organic compounds are different types of organic compounds. It may be a cyclic, it may be aromatic, it may be alicyclic, like this. Don't think like this. But on the basis of functional group, organic compounds may be alcohol, haloalkane, carboxylic acid, aldehyde, ketone, like this. So these are some important classification of what? Organic compounds. So we discuss what are the properties of organic compound, which type of compound are called organic compounds, and what are the classification. Then next thing we will discuss, that very important thing is types of chain, carbon chain. That is also important. Just I want to reflect some basic knowledge regarding the organic chemistry for yours at class 10 standard. So types of carbon chain. On the basis of carbon chain may be, already I have told you that one is open chain, another is what? It may be a open chain, or it may be a cyclic chain. Maybe open chain or cyclic. Already I have told you. This is your open chain. You can say this is open chain. These are carbon atom. What are the other atoms or groups or atoms? We have not discussed this thing, but we are seeing only carbon. As organic compound is a main composition carbon. Without carbon atom, without carbon chain, organic compound is not possible. We are giving more stress to carbon. So if both end are open, that is called open chain. If end is closed, like this, suppose it is closed, both are closed, so it is called cyclic. It is cyclic compound. It is open chain. And the open chain compound, this open chain compound again may be two types. What is this? Straight chain or branch chain? Straight chain or branch chain. Straight chain or branch chain. Straight chain, I can know the carbon chain is straight. Straight means don't confuse, you don't apply the physics and mathematics. Straight means there is one line. It is not like this. As per the chemistry, the chain is straight means the carbon, any one carbon attached to maximum 2 carbon is a very important concept. Any one carbon in the chain, you take the chain, but it should be open. If the carbon chain, any carbon atom attached to maximum 2 carbon, that is called your straight chain. For example, this is carbon, this is carbon, this is carbon, this is carbon, this is also carbon. But you see, you take carbon number 1, carbon number 2, 3, 4, 5. You see carbon number 2 attached to how many carbon? 2 carbon. Carbon number 3 attached to 2 carbon. Carbon number 4 attached to 2 carbon. Carbon number 5 attached to 1 carbon. Carbon number 1 attached to 1 carbon. So what is the concept? Any carbon you select, it must attach to, or it will be attached to maximum 2 carbon. So here maximum 2 is here. 1 is also present, but maximum 2. That's why it is a straight. This is also a straight chain. Don't confuse. If you it is showing like branch, no, it is not a branch. It is also straight. Because you see 1, 2, 3, 4. Carbon number 2 attached to 2 carbon. Carbon number 3 attached to 2 carbon. That's why it is a straight chain. So this is regarding the straight chain. What is branch chain? Just somewhat different. What? Minimum 3 carbon. Minimum 3 carbon. Minimum 3 carbons attached. For example, you see suppose like this. This is the carbon. These are carbon. So 1, 2, 3, 4. Total 4 carbon is there. If you see carbon number 2, carbon number 2 attached to how many carbon? 1, 2, 3. So minimum 3. But you see here this 1, 2, 3, 4, suppose 5. Carbon number 5 attached to how many carbon? 1, 2, 3, 4. 4 carbon. More than 3. Minimum 3. Minimum 3. Here maximum 2. That is very important word. If maximum 2, that is straight. If minimum 3, starting from 3, like this, then it will be a branch chain. So this is regarding types of carbon open chain. Open chain are 2 types, straight chain or branch chain. So this is regarding what? Types of carbon atom. Another thing is still types of carbon atom. Types of carbon atom. That is also not required, but it is some better for your competitive examination. Types of carbon. Carbon in organic compound generally 3 types of carbon. If carbon attached to 1 carbon, that is primary. It is also primary symbol is 1, 0, 1, 0, primary. 1, 1. It is attached to 1, it is also attached to 1. Then this carbon attached to how many carbon? This carbon attached to 2 carbon, so it is secondary. And this carbon is attached to 1 carbon, it is primary. It is attached to 1 carbon, it is also primary. So 2 not means secondary, 1 not means primary. If you say this one, suppose like this, okay? This carbon, this is attached to 1 primary, 1 carbon. It is also primary. It is primary because this carbon attached to 1 carbon directly. Primary. This carbon attached to 3 carbon. So it is tertiary. So on the basis of number of carbon atom joined to the particular carbon atom, it may be primary, secondary, and tertiary. So there are 3 types of carbon atom. That is primary, secondary, tertiary. So three types of. So this is primary. Primary means it is attached to one carbon. Secondary means it will attach to two carbon directly. Tertiary means it is attached to three carbon. 1, 2, 3. So on the basis of number of carbon atom attached to the particular carbon atom, then the carbon atom will be primary, secondary, tertiary. Then this is about the carbon chain. Okay. Then have you written this thing? Completed or not? Okay. I am giving half minute, 1 minute. You complete and then I will rub the plug. Okay. Okay. You finish this one. So what are the next concept we will discuss? Organic compound containing carbon and hydrogen. These are called hydrocarbons. Hydrocarbon means containing carbon and hydrogen. Containing carbon and hydrogen. So these are called hydrocarbon. The compounds containing carbon and hydrogen are called hydrocarbon. From hydrocarbon we can derive other organic compound. From hydrocarbon you can prepare that derive alcohol, acid, so many organic compounds. But basic carbon chain, basic organic compound is hydrocarbon. Remember, the basic compound, organic compound is hydrocarbon containing carbon and hydrogen. These are the hydrocarbon. Hydrocarbons generally you can say it is three types. Three types of hydrocarbon. First one, if you see divide, mainly two types you can say. All hydrocarbon mainly two types. One is saturated, that is called saturated hydrocarbon. Another one is saturated hydrocarbon, HC. Another is unsaturated. Hydrocarbon. So mainly hydrocarbon containing carbon and hydrogen. It again is two types: saturated hydrocarbon, unsaturated hydrocarbon. Saturated means, I can know saturated. Saturated means it has carbon-carbon single bond. This is very important characteristic of saturated hydrocarbon, means it has only carbon-carbon single covalent bond. Already we discussed types of covalent bond: single bond, double bond, triple bond. So saturated hydrocarbon means having carbon-carbon single bond, but unsaturated means it may be carbon-carbon double bond or carbon-carbon triple bond, and both are called multiple bond. Multiple bond means more than one. Multiple bond means a double bond or maybe a triple bond, and both this carbon having carbon-carbon double bond or compound having carbon-carbon double bond, these are called alkene. This type of hydrocarbon is called alkene, means double bond is there. And carbon-carbon triple bond is called alkyne. YNE, alkyne. Okay? And the carbon-carbon single bond, this is called alkane. Alkane. So alkane, alkene, alkyne, all are hydrocarbon. All are hydrocarbon. You know your wax. Example, if you write example, your wax, petrol, diesel, like this. Petrol, diesel, all are alkane, you can say. And your unsaturated hydrocarbon you can only, that is containing both also. It may be also like this, your wax, your maybe petrol, diesel, but both are same. Both are hydrocarbon. It also exists in petrol and diesel. Some petrol, diesel also having double bond, triple bond. Okay, and having double bond and triple bond compound, but both are hydrocarbon. So specific, maybe it may be wax, it may be kerosene, maybe petrol, or maybe diesel, all having hydrocarbon. Maybe a double bond or maybe a single. It is a mixture. It is not a single compound. It is a mixture of hydrocarbon. So these are the types of hydrocarbon: alkane, alkene, and alkyne. Then very important thing, let us discuss, that is what is isomer. What are isomers? Which type of organic compounds are called isomers? Isomer means compounds having same molecular formula, formula is same. Formula same means molecular formula, or molecular formula same number of atoms. Compounds having same molecular formula but different structure. Compounds having same molecular formula but different structures are called isomers. These isomers shows different physical and chemical properties. Having same molecular formula but different structure means isomers, and showing different physical and chemical properties. All isomers, they have different physical and chemical properties due to different structure, only due to different structure, but formula is same. So these are called isomers. For example, you take the example, suppose you see C has 3, C has 2, C has 2, C has 3. Suppose this is a carbon chain. Let us see. This is a carbon chain having 4 carbon. 1, 2, 3, 4. Already you know carbon has valency 4. So when it forms covalent bond, it must satisfy the tetravalency. If you see this carbon is a single bond, so 3 hydrogen required to satisfy the valency of first carbon. Carbon number 1, carbon number 2, carbon number 3, carbon number 4. So all are satisfying tetravalency. Already 1 bond, so 3 required. Already 2 bond, both sides, so 2 hydrogen required. 2 bond, 2 hydrogen required. 1 bond, 3. Like this, you will satisfy the valence of carbon to filling the hydrogen, to substituting the hydrogen. So this is called a straight chain. Already we have discussed, this is a straight chain containing maximum 2 carbon. It is a straight chain. But this can be written as, here you see, what is the molecular formula? C4, this is C4, how many hydrogen? H10, C4, H10. But if you write like this, now you see it is straight up branch. Same 1, 2, 3, 4 carbon. 1, 2, 3, 4 carbon. Total carbon 4. Total number of carbon 4. But it is a straight chain, it is a branch chain. And if you fill up 1 carbon, how many hydrogen required? 3 hydrogen. Here how many of bond? 1, 2, 3. So 1 hydrogen required. This is only 1, so required 3 hydrogen. Here 1, required 3 hydrogen. It is also formula same, C4H10. Formula is same, but it is a straight chain, it is a branch chain. So that's these two. We will discuss the nomenclature later. This it is a organic compound, it is a hydrocarbon. It is one type of hydrocarbon. It is also one type of hydrocarbon taking 4 carbon atoms and 10 hydrogen atom. But this structure is straight chain. This structure is branch chain. The property is not same. Property of these two compounds are not same. So same formula. C4H10, C4H10. Same formula but different structure. That's why these are called isomer. This compound A and B called A and B. A and B are called isomers. Because same formula but different structures. That's why these are called isomers. Isomers, for example, I will give you, isomers may be different. You will read in higher class different types of isomers. Chain isomer, this is called chain isomer because chain is different. When chain will differ, that is called chain isomer. This isomer is chain isomer because only differ in chain. But when position, suppose another example, this is first example. Second example, suppose CH3, CH2, CH, CH2. You see, satisfy the valency, tetravalency. So this compound can be written as this 4 carbon. I will double bond here. Here you check. Here bond double bond is first position, but here double bond second position. But having same 4 carbon, hydrogen you count, number of hydrogen you count, then you can understand. Number of here C4, C4H8. Here also it is C4H8. Formula same. C4H8, C4H8. But it is straight, it is also straight. Both are same. But only difference in position of double bond. Here double bond position from 1, 2, 3, 4. 1, 2, 3, 4. In between 1 and 2 carbon, here between 2 and 3 carbon. So position changes. That's why this isomer is called position isomer. This is called position isomer. When the particular functional group position will be changed, that is called position isomer. When the carbon chain will be changed, here carbon chain is same. Just you see, straight chain. But it is straight chain and branch chain. When chain nature will be changed, straight to branch, branch to straight, or branch to straight to cyclic, that is called chain isomer. And this is called a position isomer. So different types of isomers also possible in organic compounds. That's why organic compounds are large in number. Because you see, taking same carbon, same hydrogen, we can draw large number of organic compounds, taking different structure. So in this way, organic compounds shows different isomeric forms. Then next we'll discuss homologous series. Homologous series, that is also very important concept in organic chemistry, that is homologous, formation of homologous. You see the term, homo means same, logos means that different parts. Something is same, but something is different. So homologous, if taking together, if you take together, then that will be a homologous series. What is the factual definition of homologous series? Which type of organic compounds are homologous to each other? We know this thing. Group of organic compounds differ from one another in the molecular formula. Group of organic compounds differ from one another in the molecular formula by whole number multiple of CH2 group. Again I am repeating, group of organic compounds differ from one another in the molecular formula by a whole number multiple of CH2 group. This is called methylene group. The name of this group is called methylene. This is called methylene. This is called methylene group. When the differing CH2 group, 1 CH2, 2 CH2 like this, these are called what? This group of organic compound are called homologous series. Group of organic compound differ from one another in the molecular formula by whole number multiple of CH2 group is called homologous series. And each member is called homologous. Homologous to each other. Each member is homologous. A is homologous with B. B is homologous with C. So each member is called homologous, and a group of compounds are called this series, that is homologous series, and the phenomenon is called homology. The phenomenon is called homology. By this process, that one homologous produced from another homologous, that is called homology. For examples, let us take examples. Homologous. Suppose CH2, CH3, CH2, CH3. If you combine the formula, that is C3H8, it is one organic compound having 3 carbon and 8 hydrogen. If I write CH3, CH2, CH2, CH3, by satisfying the valence of carbon, I am writing tetravalency. So if you see here, how many carbon? C4. How many hydrogen? H10. Similarly, if you write CH3, CH2, 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 CH3. Here how much? C5, H12. You count number of carbon atom and hydrogen atom. C1, 2, 3, 4, 5. Hydrogen is 12. Here 1, 2, 3, 4. C4, H10. Like this. So if you see C3H8 and C4H10, how much differ? What is the difference in formula? C3, C4, 1 carbon, 1 carbon. Then H10 and H8, 2 hydrogen. So if you add CH2 in C3H8, you are getting C4H10. So these two are homologous because they are differing one CH2 group. Similarly, this one C4H5, C, and H10, H12, CH2. This is also one CH2. So C4H10 and C5H12, it is also homologous. But come to this one. Here C3, here C5, that is C2, and H12, H8, that is H4. C2H4, if you add C2H4 in C3H8, it will be again C5H12. And C2H4 is 2 times of CH2. That's why if you add 2 CH2 in this compound, you are getting this one. What is the definition? What we have written? Group of organic compounds differ from one another in the molecular formula. They differ in molecular formula. How much? By whole number multiple of CH2 group. Means 1 CH2, 2 CH2, 3 CH2 can be differ. Here first one, second one, 1 CH2 differ. Second one, third one, 1 CH2 differ. First one and third one, 2 CH2 differ. That's why it is homologous. It is also homologous. It is also homologous. This is compound A, this is compound B, this is compound C. So A, B, C are, write down, A, B, C are homologous to each other. Homologous to each other. And the group of A, B, C called what? Homologous series. Called homologous series. Taking together is called homologous series. Individual members are called homologous. So this is regarding some basic concept in organic chemistry. In the next class, we will discuss more other concepts, other information regarding organic chemistry, practice this thing that we have discussed here. So in the next class, we will discuss more. Okay?